in my demo, I'm going to display something that's a lot more amateur, fall over, and not recommend it for any kind of serious use. But I think it highlights some really cool, interesting technologies coming along. I'm hoping to convince you of two things. One, polars in DuckDB are amazing for data analysis, not just what Joe showed you, but probably more focused on DuckDB. And two, I think we will all be using Parquet and PyRO in the future. And if you notice, Joe mentioned that polars on the back end uses the PyRO format for storing data in memory. So this is the two things I'm hoping to convince you. To do that, I wanted to look at the problem that I'm sure most people on this call have commonly seen. Imagine someone wants to analyze data and share it. One such way they would do it is using these steps. So first, they query a big data platform using a special SQL notation. They pull it back to Python. 2, they run some form of slow pandas analysis on it. 3, they create their analysis. 4, they convert and upload it to a database using an API, maybe Kola. And 5, they create a dashboard in the front end. So the parts I've highlighted in red can be painful, and I would suggest we can maybe get rid of some of them. So what I'm hoping to do is 3 steps: run fast SQL and polars against data, both remote and local. 2, create the analysis, which is the key thing I'm trying to do. And 3, create the dashboard in the front end. So removing those more painful steps. Okay, let's skip to the actual demo. Okay, so I'm going to start PythonDB. It is basically a Python module, but here I've also wrapped it so you can just download it standalone. But you should be able to do pip install PythonDB and import PythonDB. You can see this is a fairly standard Python prompt. It's repeated, that's just a thing with my debugging. And I can import packages like you normally would and call them. So all fairly standard Python. I have already imported pandas as PD, so I can create a pandas data frame. I've already imported polars as PL, so I can create a polars data frame. For those that aren't as familiar with Python like I was, a data frame is just a table shape structure. Pandas was a much older library from about 2010 based on NumPy that is extremely popular. Polars is a new one out in the last probably 2-3 years that's more column oriented and significantly faster, but they both just represent tables. And the last part I want to introduce is DuckDB. So DuckDB is a free, open source, column-oriented database. You can import it as a Python module like I'm doing here, or it's available to embed in anything. So QStudio embeds it, and there's a number of products embedded. And it basically lets you perform SQL against column-oriented data. Here I'm performing it against PLDF, which was the polars data frame I created earlier. And a select works as you would expect. I can also use DuckDB to query remote data. So here I'm reading Parquet from an HTTP data source. And that will push the query down remotely to try and run efficiently where possible. So I can query Parquet. Parquet is an optimized on-disk structure, basically almost column-oriented. And I will go back to cover it in more detail. And similarly, I can read things like CSV, and I can query S3-based data and a whole host of other remote kind of standards. So basically, what I'm trying to show is you can use DuckDB to query data remotely. And here I've pulled it back to a local table, and I could do a query on the local one. Nothing too earth-shattering. Okay, and probably the last one I want to do is save that mortgage to a local Parquet file. And if I open the folder somewhere, you see it's created a little Parquet file. So I showed that we can do remote queries. I didn't want to chance it for demo purposes, so I've created a data subset locally, and the only real key part is I'm going to load it in, and it's equities data. So it's loads of firms have to declare certain trades for the 605 rule in equities. So you can see Bank of America every month reports their executions and details on a per ticker basis. what I want to do is taking that data that I've kind of generated, I'm going to copy the table and I'm going to partition it by date. And if I run that, you'll see that I begin to get a monthly folder with one date per folder. And if I pull across my CPU monitor, you'll see DuckDB is very efficiently using all 8 cores in my machine. So it's maxing it out. And it's just going through and saving a Parquet file in each of these folders representing one date. I think the data is about 2.5 gigabytes. It's going to save a ton of files to each one. Hopefully it'll finish in 10 seconds or so. There we go. And to make things handy for myself, I'm going to create a view M, just so it's shorter, based on that. And this standard is called Hive partitioning. So it works with DuckDB that I'm demoing, but it also works with other things. And it basically says, in below here, find the partition in the middle, find all the parquets, and create the view M.
Hey Ryan, Terry here. Just quick question. Does this state partitioning then make it more efficient and faster to query parquets?
It depends what your query is. I'll go into a bit of detail. I know you'll want to see it, Terry. Okay, so to give you a slight description of what Parquet is now, it's an efficient column-oriented data file format. I believe it originated from Hadoop. There was a similar one called Org, but it's pretty much become the standard. And on the top is row-based storage layout, which standard databases use. Column-based in the middle is probably what you're more familiar with, for example, in KDB, where it stores the column sequential, and in KDB it's actually separate per file. Parquet is a hybrid of that, so they're trying to get the best of both worlds to a degree. It has the concept of row groups, so let's say it takes the first 1,000 rows and it stores them column sequential. So this has a row group size of 2, so it stores A, B, and then it goes to the next one. So it's a hybrid structure. Okay, so back to my table M that I created, that again is one date per folder and a Parquet in each one. And I can do queries such as select, go back up, where date equals 2023-041, ticker equals meta. So to answer your question, it will check what folders exist. It will only read this one Parquet file. And in particular, we'll read the header to try and look at the metadata that I'll demonstrate in a minute to only fetch the sections that it needs. So to dive into an example of that, actually before that, I want to show something that is particular to PythonDB. So far, all of the commands I've been running are standard Python commands. PythonDB, this little exe that I've created, tries to make some things handier. So I can do dk greater than, and it runs it in DuckDB mode. So I don't need to escape the query. Or what I can do is tell it to always run in DuckDB mode. It just lets me enter the query in a lot more sensible way. Okay, so to Terry's question, the folder and the Parquet, it's useful to look at the metadata of the Parquet file. So if I look at the particular one below 0401, and at that, you get a whole bunch of info, tons, but I am going to reduce it down to something more sensible. So what this is telling us is, for that Parquet file within the date folder, we're looking at the firm ID column. For that column, there are 22 row groups. This is the count within each row group, so it's dynamic. And this tells you the minimum and maximum value in the column. So I stored this sorted on the firm ID column. So if you're coming from KDB, that's part of it. And yes, if you do a query such as select number of covered orders from M, where date equals 2023-0401. It will only go to 2023-0401. It will look at the metadata, because firm ID is virtue, and only look within those row groups. And it will only pull out the column for non-covered orders sequentially within that block. Terry, did that answer your question?
Yeah, that's good, Elliot. Thanks.
And if you wanted to see this, so this is a little program for monitoring in Windows. If I perform that query, you'll see this little program tells me, yes, it scanned all of the folders to see what dates existed, but when it came to reading, let's see, you'll see here the offset and the length. So length 1 means it's reading very, very little. And actually, these are all sequential. It just recorded it in a strange way. But you'll notice the length is very small. So it's reading a very small amount of data from the actual file itself. So when you do that select, it checks what folders exist, only looks in the one folder, looks in the Parquet file, looks at the metadata to see that virtue is all in one area, and only reads that section. Okay, so you have a fast, efficient, free, open source partition database. Pretty cool, or at least I think so. What else did I want to show?
Ryan, see that hybrid model? Is that something that you set then locally? What was it? Row group size 2?
Oh, that was just a mentioned example to give you an idea of the layout. You can control the layout.
Is that configurable, or?
It is, but not easily.
Is there a benefit to it, or?
Oh yeah, I mean, they've added a lot onto the standard lately. I think you could even capture that if you want it. Say I sort it on ticker, and I think there's now a way to convey that it's sorted on time to get the kind of optimizations you've probably seen elsewhere.
Okay, thanks.
Okay, so that was Parquet. Okay, so this little cartoon that I sent is a good way of trying to remember what all these pieces were. The snake is for Python, which is the language for data analysis. The duck is for DuckDB, the fast, free column database that you saw was really quick and could handle partition data. NumPy and Pandas, most of you will be familiar with. Polars, similar to what Joe showed, is a fast data frame technology, and they call it data frames for the new era. Notice the dates here. DuckDB only hit version 1 in June this year, and Polars only hit version 1 in July. So it's pretty new and exciting time. And lastly, I put the dolphin in because PythonDB lets you query all of this as if it's a MySQL database. The one other thing I would mention is that both DuckDB and Polars have very tight integration with Parquet and PyArrow. Okay, so PythonDB, so far you've seen that it allows the nice little notation. What it also allows me to do, it's in there. If you have any SQL ID or any business intelligence tool, you can add a server MySQL, so I can test it, I can add it, and those queries that I was running previously, so let's go for count star, very boring. Oh, I need to switch to the MySQL server, select count star, but there you go. It treats it exactly as if it's a MySQL database. And you can perform all the queries that DuckDB supports, or you could perform Python queries. DuckDB has some really nice features. Here's an example of a pivot. So I've selected the number, the number of trades executed at improvement, and then I've pivoted by firm to get this kind of stacked bar chart. I can take that query and I can go to basically any tool, Tableau, Panopticon, Superset, and again, you can add a MySQL connection, and then that allows you to add a dashboard, send your query, and it will appear. And if I add another one, if I use the 3 arrows, it makes it do Python syntax, and I can show you that it would do random.random to prove that it is querying that backend. And I could set it at a very low timer, and you'll see it's ticking away. And in the background, it's scrolling because it's performing a query. And I have debug output. So yeah, PythonDB basically wraps polars, DuckDB, and Python and lets you query it as if it's a MySQL database, allowing you to reuse all the tools that you would have. So when I said, remember at the start, I laid out, typical steps are some kind of big data platform, query it, run your slow pandas, create your analysis, convert and upload it, create dashboard. We've got rid of lots of those steps. Our polars and DuckDB have done all the good work. So basically, DuckDB and polars you can use for remote data and local data, and it's fast for both. That allows you to create your analysis. And then this kind of PythonDB thing, let me skip the step of sending it anywhere else and instantly query it as if it was a MySQL database. I'm not going to demo it, but I can assure you that polars has an SQL method, and similar to how we had the DuckDB mode, there's a polars SQL mode, and it supports that. So you don't just have one fast column-oriented SQL, you have multiple. And there's other databases such as QuestDB that support this kind of Parquet Hive partition format. So there's actually loads, and they're all free and open source, which is pretty cool. So yeah, I guess, and you can see it here, Apache Arrow and similar Parquet is kind of becoming the standard. The idea behind PyArrow was that instead of everyone having to do different IPCs, there would be a standard, and it would be free to transfer it between them and to reuse those memory blocks. And hopefully I convinced you of at least 2 things, that polars and DuckDB are amazing for data analysis, and we will probably be using them in the future.